Hi there, John Bishop here. I'm here with my good friend, Dr. Nancy Flournoy and Virginia. We are going to be taking about 45 minutes, right, Nancy, to
I'd say so.
explain about the SP6 Complete phototherapy patch from LifeWave. So I'm gonna let Nancy give a little introduction of herself first, and then we'll do her slide presentation.
Okay, and I'll share my screen, start sharing my screen while I talk. I'm Nancy Flournoy, and I have spent my career doing clinical trial experimental design in statistics and statistical methods. And so I have a lot of scientific background, but I had not learned what had happened in the last 20, 30, 40 years in biochemistry and chemistry. And these patches came along and I've seen them work on people and they're so exciting that I have made a point to try and find out what I can find out about them. So can you tell me if you can see the presentation okay?
Yes, can see it very clearly.
Okay. I have to get a couple of things from Zoom that are right on top of what I see. Start. Okay, so we are here tonight to, we've been doing this series, talking about one patch each time, every 2 Fridays a month, first and third Friday. And tonight we're talking about a patch called SP6 Complete. And what you have here is a little copy of what they call a sleeve, which is what they put the patches into, which is what LifeWave puts the patches into. And this is a little patch down here. You can see it's just a little more than an inch in diameter. And it goes on just like a little bandage. So it's small, it's easy to use. This particular patch, what's written on the to the right of the sleeve are what the company says to promote the patch. And that is that it will complement a weight loss program. So, you know, it doesn't necessarily work all on its own, but it may help to reduce cravings and it may help to reduce appetite. So we're going to take a deep dive into what's going on. And first I will say that on the patch is a crystal. LifeWave makes puts crystals between 2 pieces of plastic. They're configured in such a way that when that they will use one's individual body heat to make them run, and when they run, they're going to emit light frequencies back into the body that are going to signal the body to produce specific metabolites. Now, some of the patches we have heard from the CEO, David Schmidt, the exact molecule that is being targeted in terms of the frequencies. For SP6, we don't have that specific information. And so we have to sort of speculate a little more generally as to what's going on, but we do have some hints from him. And I will just say that the patches are a passive wireless nanotechnology that relies on these non-toxic organic crystals. So, so we're going to talk about what's known about hunger and what's known about craving. And then we'll talk about the patch specifically and try to draw some inferences and some connections. And so this is, you know, my search for trying to understand what's going on, and I invite you to join with me. So this is the only patch that's named after a meridian, acupuncture meridian point. Some of the patches are named after the molecules that are being targeted. Some of them have, you know, other names, but This is the only patch that's actually named after a meridian point. So I thought I would start by discussing that meridian point, because one can get an idea as to what David was trying to accomplish when he designed this particular one. So SP6 is the spleen 6 point, and you can see in this picture that if you put your fingers right above your ankle bone and go up 4 fingers, you're right at the spot which is one of the spots that's recommended for placing this patch. So in traditional Chinese medicine, the spleen and the stomach meridians the spleen and the stomach are considered the acquired foundation of life. And the organs are responsible, for receiving the food and drink, digesting them, making them into the nutrients that you need, and making body fluids, and then distributing these around the body. The spleen in particular also controls blood flow and rules muscles and flesh. The spleen meridian, I'll show you a picture of it in the next slide or two, actually comes up from here, down here at the ankle, and ends up at the mouth. And it actually, how the spleen is functioning can be seen, shows up in your lips. It's pretty interesting. The spleen and the stomach meridians communicate with each other. And in fact, one of the reasons for this particular point being powerful is that there are 3 meridians that come together there. That is the spleen, the kidney, and the liver meridians. So it's also true that the SP6 point in acupuncture is a point that is used for treating digestive, gynecological, and emotional conditions. So for this talk, we're particularly interested in the reference to the digestive issues. Now, here's the spleen point again. And so we've got, at this point, we've got the spleen and the stomach meridians coming together. And one thing that is that David noted in a talk that he recently gave is that from this spleen point, then in terms of the stomach meridian, one has a superhighway that goes directly to the hypothalamus, which is here in the brain. And we'll talk more about that. And then what I wanted to, so I say, okay, this is a superhighway. And some people have had wonderful experience with acupuncture, and some people think it's all foo-foo. And just for those who think it's foo-foo, I will say that there is lots of physical documentation that the meridian system exists. One can put dye in acupuncture points and see where the dye goes. One can do heat maps, infrared heat maps, and follow the energy that's going through the meridians. There are a number of physical ways in which these meridians have been explored that are quite scientific, which is not to make comments on they cure this or cure that, but just to say that the system is a fact. And one of the more exciting current research on the meridian system at all are these things called Bohang ducts. And so Bohang is a man's name. He was in North Korea, and he discovered these ducts in 1965, but they didn't get any attention because he's in North Korea. And so it took a while for his research to filter into, it's been taken up by research teams in South Korea and in Italy. And what you're seeing a picture of here on the left is a lymph duct, and it's spread open. So you're looking at the inside of the lymph duct, and under normal staining, you would not see this purple line running down it. And with a particular kind of staining, what is being exposed is a duct within the duct. And you can see a cross section of it here. You've got the lymph duct, and then you've got the duct inside the duct. And it's believed by the scientists that are researching this, that this is the physical manifestation of the acupuncture meridian system. And they're actively trying to map what they find physically to the traditional Chinese medicine system. And there's a paper by South Korean Dr. So, 2009, which I had seen a number of papers before, but this is a recent review of previous work. So it's pretty exciting. Okay. So again, just to continue on the Chinese medicine, the relationship, we're talking about hunger. So a lot of hunger is deeply related to emotions and how you feel about whether you feel like eating or not eating. And so this is the Chinese medicine relationship between the various organs and emotions. And you can see you go from the liver and the gallbladder with anger and frustration. That's going to be related to, again, all of these emotions are related to your how you feel about eating. The heart and the small intestines are related to hate and impatience, the spleen and the stomach to worry and anxiety, the lung to large intestine, sadness and depression, and the kidney and bladder to fear and flight. So we have that in the background because all of these organs are going to come up in this talk, except I think the lung. And I did see something on the lung, but I don't think I have anything that I'm going to say about it. Now in Western medicine, if we just take these three, if we take the organs that go with the three meridians that cross at that site for which this patch is named, we find that the liver stores excess glucose and then releases it to cover the body's energy requirements. So the liver is very important in weight and hunger and the desire for food. The spleen maintains the levels of fluid in your body, among other things. But that includes edema. So if you're swelling with excess fluids, then the spleen is involved, or if you're dehydrated, the spleen is involved. It's involved with maintaining a proper fluid system. It also filters and stores your blood. And then the kidney is associated with food insecurity, particularly with people with chronic illnesses. So that's what Western medicine would have to say about these three organs in connection with hunger and food. So now, as I said, from the SP6 acupuncture spots, there is a superhighway going to the hypothalamus, which is this little spot up here in the brain. It's at the very top of this slide. And I've showed this slide before, but I'll just remind you that all these neurotransmitters, which are molecules that send signals to the body to do different things, a lot of them are generated here in the hypothalamus, and they cause hormones to get secreted and messages to come down here to the pituitary glands, which look like a couple of testicles hanging off of them and just very, very tiny. And then from there, the messengers, the neurotransmitters, go out to all of these organs all around the body, which then send out their own hormones to control what's going on. So we're talking about a very interrelated system. We have hormones going to the kidney, which we were just talking about. We have kidney hormones going to the adrenal glands. In particular, the thyroid has some involvement with hunger and food. And so, so trying to target the operations in the hypothalamus can have a lot to do with what's going on with weight and food. So what I did here, this is a little slice. This picture is a little slice of the hypothalamus, looking at it horizontally. And the little green spots here are the extreme lateral part of it. And they are responsible for the control of food intake. And then the little red piece of the hypothalamus that's more towards the interior, that's responsible for your feelings of satiation, of being full. And so this hypothalamus is actually the control center of the autonomic nervous system, which integrates and tries to make homeostasis, tries to make everything, a lot of the physiological processes work together. And at the bottom of the slide, you can see that it's trying to balance hunger and thirst and food intake and body temperature and a host of other things. And so it also links the autonomic nervous system then with the endocrine system and links those directly to regulate your internal environment, as in the body temperature, etc. So this is a very important location, both directly for what it does directly and also indirectly for how it's going to affect what happens that's relevant in other parts of the body. So for the rest of the talk, this is basically what I'm going to cover. First, we'll talk about what regulates hunger, and then I'll describe some different types of cravings. They're called craver types. So people have classified cravers into 5 different types. And then as we go through that, different chemicals will get mentioned. And so I'll try to come back to talking a little bit about the different chemicals and and so looking at the issue from the chemical point of view. And then we'll finish by talking about the SP6 and the research that's been done on it. So hunger regulation. So start out by looking down here at the little rats. You can look on the left, and you have fat tissue. Adipose tissue is going to send a message to make these little things called leptins, represented by little red triangles, and they send a message up to the hypothalamus. And in the hypothalamus, you have this molecule that's depicted in red up here above the I don't know if it's a mouse or a rat. But you can see these little red triangles are lodged into these little green things that are really symbolize receptors. And when everything is plugged, when all these receptors are plugged, you're full and you're going to stop eating. And on the right-hand side, we have I'll call him a mouse. We have the mouse who's eating a lot. He's got a lot of fat cells, and he's got a lot of the leptin here. But when it comes up to the thalamus, there's something that interferes with it. You see these little scissors, and the receptor sites get clipped off, so they're not available to take these receptors of the leptin. And so when the leptin can't attach to these molecules in the hypothalamus, then you just stay hungry and you keep eating. Okay, so as a description then, the leptin is a hormone, and it's going to decrease your food intake and increase your energy output. And it's produced in, actually the adipose cells are in the small intestine. And so its primary function is to make sure you have a large enough fat store to get you through the winter. It's there to help you survive. And on the other hand, you have another hormone, ghrelin, which works activates cells in the pituitary gland and the hypothalamus. and they make you hungry. And so these two hormones have to be balanced and have to work appropriately. So there are 4 hypotheses that relate to hunger regulation. And as far as I can tell, reading them, it seems to me like they all 4 are in effect because they relate to things that make perfect sense when you read them. So we have a lipostatic on the left top and glucostatic on the right, which lipos fat, glucose essentially sugar. So it's reasonable to think that our hunger regulation is going to involve the regulation of fat and involve the regulation of sugar. And that's basically what those hypotheses say. The other 2 hypotheses is there's a gut peptide. So that's saying that there's hormones in your GI tract and they will inhibit, or they're thought to inhibit, food intake. So that would mean that when there's a lot of food that's being processed through your gastrointestinal system, your body would recognize this and stop and say, okay, you've got enough, you're full, you can stop eating now. And the 4th hypothesis is thermostatic, that is, when it gets cold, you get hungry. And I think everybody who's been in a place that's cold, gone out in the snow or whatever, has had the sense of their appetite being stimulated because they're cold. So I think really, even though, a lot of this still, doesn't have a lot of scientific verification in humans, a lot of it makes perfect sense. And we can all think of these hypotheses as being operational. So now, craving is an intense feeling of wanting. And their cravers have been classified into 4 types, and they're sort of overlapping, and we'll see in terms of chemicals and things that there's a lot of overlap. So the 5 are the comfort cravers, the stressed cravers, the depressed cravers, the fatigued cravers, and the crashed cravers. And each type of craving is associated with a reduction in some sort of chemical. So for comfort, it's low endorphins, and we'll see these a little more as we go along. But for the comfort, it's low endorphins. The stressed, it's low GABA. For the depressed, it's low serotonin. For the fatigued, it's low catecholamines, and I'll tell you what that is. And then the one that's sort of different, it seems qualitatively different, is the crashed, which is your low blood sugar, which could be related to diabetes, but also could be related to your eating habits. Okay, so let's talk about the comfort cravers. I've tended to put the chemicals that come up in purple. As I said, we'll come back and take a point of view we'll take the chemical point of view. We'll look at the chemicals a little when we've gone through what each of the types of cravers are. So we won't focus too much on them. If you see a big word, just, put it aside and we'll come back to it. So comfort cravers are the most common, and they kind of got hooked on endorphin surges, like sugar highs. And so they go for baked goods, chocolate, ice cream, cakes, pastry, etc. And they're looking for a relief from emotional pain, and they're looking for the pleasure that one would prefer they get from endorphins directly, as opposed to needing the food to simulate that. So the comfort food craving can be mellowed down by eating a lot of protein. Just every time you feel like you want sugar, eat a steak or something. This chemical phenylalanine is it's an amino acid, and it will produce a strong sense of well-being without the assistance of the ice cream and candy. So if you can get that amino acid, enough of it, then it should take care of the comfort craving. The fatigued cravers, and here's another mouthful of a word, are low in catecholamines. So what are they? Well, the examples are dopamine, norepinephrine, and epinephrine. And epinephrine is also known as adrenaline. So these are chemicals, molecules that play a big role in the fight or flight complex. And so, if you're fatigued, it may be because you've just been revved up to the fight or flight situation too much, too long. They're actually hormones, and they are made in the adrenal glands. So they're released into the body because when you're in physical and or emotional stress. So these cravers become dependent on like caffeinated beverages and pure sugar and drinks that have pure sugar in them. And they want the sugar at regular intervals. So they're not binge eaters. They want a regular intake of sugar, although dark chocolate will do well too. Then this is other chemical, tyrosine, which if they had enough of that, if a person had enough of that, it's going to fuel energizing and rewarding functions of the brain. And that's like dopamine. And then if that was doing its job in terms of fueling your energizing and rewarding functions, you would then produce good energy and focus. So that's kind of the answer one's looking for this kind of a craving. There's the depressed or serious craver, and they're low in serotonin. So serotonin is the natural appetite controller in the brain, and it's a neurotransmitter, so it signals lots of other things to control your appetite. And it includes people who gorge on carbs as opposed to the strict sugar, and they're not doing it regularly. They're more the binge eaters. So particularly in the winter or late at night or in the afternoon, they want a lot of carbs. And it's particularly at this time of day and in this situation of the seasons that the body is at its lowest levels of serotonin naturally. And so they're making the food try to do the work of the serotonin. And depressed cravers also at the same time, they feel anxious, they're negative, they feel worried and irritable along with their food cravings. And they find some peace in eating food. And we have a couple of long named chemicals. Here, the serotonin is made of tryptophan and this molecule called 5-HTP. So they are essential precursors to serotonin. Then we have the crashed cravers. And this is the low blood sugar cravers who, it may be insulin related. And I don't think I wrote, well, I do. Yeah, okay. So it can be just because people skip meals and their blood sugar gets so low that they totally crash, and then they go to eat too much because they're going like a yo-yo. And this also happens in people that don't eat enough fiber or protein or saturated fat to try and keep your blood sugar levels stable. And glutamine, we've talked about before, but we'll mention it again, is, this will happen if glutamine is not able to regulate insulin properly. So this can be a complication of diabetes. So I think we've said everything here. If the blood sugar slump is can be strong enough that the person's going to become unable to focus and even get dizzy, and so they want high carb sweets. The stressed cravers are low in GABA, so we'll mention that again when we get to the chemicals. So they like to munch on food to combat stress. And that happens when GABA is too low. And it is another neurotransmitter we'll talk about in a minute. But if you don't have enough of it, you become stressed and you have a lot of mental tension. So GABA will help relax your mind. But low GABA makes it difficult to relax your mind. And also prayer, meditation, and sometimes sleep doesn't even help. So they seek refuge in the kitchen, and they want to, really rush to eat their meals, and they're going to munch on chips and nuts and junk food. GABA is the primary inhibitory neurotransmitter between nerve cells and the brain and the spinal cord. So it blocks receptors to modulate and block impulses between nerve cells, and you want your GABA to work properly. And there's a derivative of it called theanine, which may help when GABA itself doesn't. These products can be taken, most every product I've mentioned can be taken as a supplement, or some are normally available in our literature, in our diet, but for some reason or other, the whole process isn't working satisfactorily. So I think this is the last one, the depressed craver, who's negative, worried, and irritable. In fact, I may have mentioned the depressed. I think I did the depressed craver already, so I don't need to repeat myself. So here's a summary of the amino acids on the left and the type of craving on the right. So every amino acid that was just mentioned, I have labeled here. The ones in sort of orange are precursors to the ones that follow in purple. So if everything's working, if you have the ones on the left, you're going to be making the ones on the right, and everything will be fine. And what I'd like to say is how closely they all related to each other. So again, we're thinking about where these are all made and how everything in our body works together. But structurally, we have this phenylalanine, and it is closely related to dopamine, our adrenaline, and our tyrosine. So just as a physical compound, they're very similar. And the phenylalanine can actually be converted into the tyrosine, and then it can be converted into these other neurotransmitters, the dopamine, the norepinephrine, and the adrenaline. So all of these are kind of, different branches off the same tree. Now, in the adrenal gland is where the catecholamine is actually going to stimulate the breakdown of glycogen and make it into sugar. So glycogen is the major way in which sugar, the form of which sugar is sort of stored in the body. And if you're going to actually use it, it needs to become glycogen or glucose. So that happens in right on top of the adrenal gland, which sits on top of your kidney, which you can see over here. So these chemicals are also regulated, involved in the regulation of energy expenditure and the breakdown of fat molecules. That is, you got to break them down if you're going to either dispose of them or use them for energy. In addition to that, they're involved in the production of dopamine, which is your happy reward chemical. So if they're doing their job, you're not going to be depressed. So that's one set of hormones that we've talked about. There's another set of amino acids that are also closely related to each other. And that's the glutamine, the glutamate, the GABA, and glutamate's sort of what you need because everything else can be produced from it. But if there's some problem in the system, other things can be stimulated or, well, WebMD, which puts together a synthesis of a lot of research, will tell you that there's very sketchy data on how well the supplements work, which is one reason to try the patches. But there are a lot of supplements out there that one can try if one has these particular problems. So the glutamine produces the glutamate, and then there's this circle that can go around, and the glutamate can go back and produce the glutamine. So it's a real balancing act that needs to be maintained. And this is sort of on the same collection of items, but it shows you here in this nerve cell, this picture, you have the glutamine making the glutamate, and then it comes down here and produces the GABA cells, which get spun out into the area between the nerve cells, and they'll come, the GABA will eventually come back into the brain and make this circle. In the meantime, they're causing a lot of other changes. So foods that have flavonoids in them actually function how well GABA works. And those foods include fruits and vegetables and teas and red wine. So this is all involved with the stress craving. So this chemical with the phenylalanine, now sometimes you'll see a D in front of the chemical, sometimes you'll see an L, sometimes I leave them off, although that could be important. The letter in front tells you how the chemical is bent and twisted. And that can be important because it tells you how something's going to attach to another molecule or not attach to another molecule. But sometimes I don't go into that level of detail. So this particular molecule, which we've said is important for not being a craver, is also involved in things that are related: neurological support, mood support, basic discomfort. Here it's involved in it may inhibit the production of enzymes that break down endorphins. That's actually a good thing. I mean, endorphins have a very short half-life and they make you feel good, and you really don't want them broken down too quickly. So your this particular molecule is going to help you feel better. It's going to reduce your perception of discomfort. So tyrosine is also known as, well, you can see we have this molecule phenylalanine showing up again, and tyrosine is made from it by attaching the other chemicals to it to make this combined bigger molecule. And it signals transduction in proteins, so signaling what the protein should do. And it's involved it's involved in modifying proteins to perform different functions. So if you're deficient in tyrosine, one of the signals that you're deficient is weight gain and water retention in the absence of having done something in your activity level or your diet to count for it. And then there are other symptoms which aren't so related to diet as well, but this is the one that's related to its involvement in weight. So this probably should have come earlier. We have noted that both glutamate and GABA are important in the weight and hunger maintenance. And so I just wanted to remind you that glutamate is the primary excitatory neurotransmitter, whereas GABA is the primary inhibitory neurotransmitter, and one wants them to be in an optimal balance and not all cattywampus, and that what is the normal balance changes with whether it's day or night. So again, these are all chemicals that are related in a complex system, but if you are too revved up and you're seeking, which might excite you to eat too much, then maybe looking at ways to increase GABA would be helpful, because it's going to promote relaxation and reduce your fear and anxiety and help regulate your sleep-wake cycle. I think this may be the last one, theanine, which is also produced by glutamine. So glutamine has a big job to do. It can serve as a hypotensive agent and be involved with anti-stress. So it helps to reduce anxiety, control rising blood pressure, and particular in high stress conditions. It's involved in the regulation of your peripheral nerves and your vascular system as well. So its chemical structure is very much like glutamate is the molecule that makes the glutamine and then the theanine, and GABA, of course, is made from it too. So so its chemical structure is of these all are very similar. They're just little tweaks on the same molecule, but it and they all affect each other. I guess I'll leave it at that. Oh, but I'll tell you where it comes from. It's the green tea. It's what's good in the green tea that you drink. So it is also in some mushrooms. This must be the last one. This is the long word that went with tyrosine. Oh, this is just a picture then to show you how you can start with some foods that are high in protein, and they'll make tryptophan, and then you get this 5-HTP molecule that makes the serotonin. You want the serotonin. We talked a lot about melatonin when we talked about the sleep patch. But in particular, this train of production of chemicals, if we come off this one branch of serotonin, we see that if it's not functioning properly, you're going to have cravings for carbohydrates, alcohol, and certain drugs. So that's a schematic of those molecules acting together. And serotonin affects your appetite, both. We talk about it with regard to different patches for different things that it does, but with respect to this talk, it is involved in your sense of appetite, both increasing and decreasing it. So now let's talk about the patch. And we have one, two, three, four studies. The 2012 and 2010 studies here are sort of different write-ups of the same study. So Homer Nazarin is a professor. Well, he's retired. He's a professor at, it's in Texas, El Paso, I believe. I don't, Ms., I'll say, I'm not sure, she may be doctor. Blake Greenberg is actually a practitioner, alternative medicine practitioner, so you can look her up. She actually runs the kinds of studies that were run. She did the actual physical running of the studies on the patients, and she'll do it for you for, I looked it up, it wasn't a lot of money. And Dr. Haltenweiger has passed away, and he has written some of the real fundamental baseline papers on how the LifeWave patches work. And I just read one in preparation for this talk. He's got quite an amazing insight as to how all of this fits together. So they looked at stimulating stomach 36 the acupuncture point, which in addition to the SP6 is important with respect to the stomach, digestion, but also it's on that stomach meridian that goes right up to the hypothalamus. So they are looking at different the effects of, well, I'll tell you in a minute, so I'll show you in a minute. But here's the different patch spots that they looked at the study, at these different studies. So here's the SP6, here's the stomach 36, and I forget what this one is, but it'll come up here, I'm sure. And then Dr. Nazarin and colleagues were involved in a second study that was actually a weight loss study. And then there is another weight loss study. So there is this piece of equipment called electrointerstitial scan machine. And sometimes I was really frustrated a year or so ago when I first started looking at these things, because you look it up and the first thing I started finding were these things that were saying scam this and scam that. And it was hard to find much information about the machine. Looking again now, it was much easier to come up with sound information about the machine. And I've learned a lot about it. It is licensed in many countries as a therapeutic diagnostic machine. It is not certified as a diagnostic machine in the United States, primarily because the output of the machine is given in the context of the meridian system and not in the context of the Western medicine organs. So they attempt to do that as well, but the United States regulatory authorities have had a problem with the output of the machine. They looked at all of these different organs, the hypothalamus, the liver, the pancreas, the intestines, the thyroid, and the adrenal glands. And what this machine does, I mean, they use leads, so you have like an EKG, you have leads going from one place to another, and they set up a sort of a collection of leads on different parts of the body, such that they can extrapolate, so that they will extrapolate, make a 3D extrapolation of what? Well, it's obviously electrical impedance. It's like an EKG, but it's at a level that so if the frequency was at a high enough level, then it goes right through cells. And this is at a low enough level that it goes around cells. So it's measuring how well the energy flows in the interstitial spaces, which is really where so much happens. You know, everything that's going to get into a cell has to get there through the interstitial fluid. And so it's measuring the health of, it's measuring the ability of everything to move into the places that it needs to go. And that's that. So they looked at subjects with before they patched, 30 minutes after patching, and after wearing 12 hours a day for 1 week. And they found significant changes in all of the organs except the adrenal glands. So that was cool. Now, the weight loss study, the first weight loss study was a 4-week study, and they had 20 subjects. They did not ask them to fast, or they weren't fasting ahead of time, and they rotated the patch between stomach 36 and kidney 3. This must be kidney, that's kidney 1, it says. You have to look up where kidney 3 is. So the average decrease was 3 to 3.5 kilograms in weight and 3 to 6 centimeters in waist circumference. 4 of the subjects didn't have any change at all, so the rest of the subjects had a so many of the subjects had a bigger change. Anyway, what they called success occurred in 75% of the subjects. So they were happy with that. Oops, I guess that's the, oh, I must have skipped this. This is the other weight loss study. So here they also used this was actually on SP6. They did it for 4 weeks. They studied them for 4 weeks. They had 23 at one site who were fasting. They had 21 at a site that were not fasting, and they had 20 at a different site that were not fasting. And they said there was general agreement between the different sites. And on average, they lost 5 pounds of weight. Their waist size went down 1.5 inches. They had a 20% improvement in weight loss efficiency with 2-day fasting as compared to non-fasting. I should have looked up what they actually meant by that. I think what they're talking about is intermittent fasting, because David is very big on intermittent fasting now. That is trying to compress the amount that you eat into like 8 hours or something. And I haven't really studied why that is thought to be so important, and how you don't end up having sugar crashes when you do that, but it is worth looking into. There was a 6.5% improvement in weight loss efficiency due to the initial 2, I just repeated. Oh, one's weight loss and one's waist loss. So, so it was better to be fasting than not fasting, is what they're saying. So that's the evidence that's out there. I will say that the patches aren't intended to cure any disease, and that if you have a serious problem, you should be talking to your physician. But I will also say that it has been proven that these patches stimulate acupuncture sites, and it has been proven that the stimulation of acupuncture sites stimulates other places in the body, like SP6 and the hypothalamus. And so it is quite intriguing to think about what might be going on here in terms of one being able to get benefits from this patch. And I would, in fact, my husband and I just started trying it. So we're trying it. We'll report in a month or so what effects we have. So with that, I will thank you all and hope I see you again in a couple weeks, same time, same place. You can find me at lightpatchscience.com, and I'd be delighted to see what anybody thinks about that website, because I kind of spent some time putting it together. If you haven't seen the film, What the Bleep Do You Know? I recommend it to you. It's a lot of fun, and it's by this wonderful scientist named Candace Pert, who's also passed away, who has this book called Molecules of Emotion, which is her, it's got some science in it, but it's also her personal life story. So I would recommend those to you. And with that, I'll turn this back to John and we can talk a little.
Thank you, Nancy. Thank you very much. Very good.
So have you tried the SP6?
I did for a month, and that was over a year ago.
So I